Okay, so here, next example. At what speed must a 1000 kilogram car approach a ramp which has a 20-degree slope and a 12-meter high at the top, such that it will just coast to the top? Meaning, unsa pila ko niyang velocity from the bottom para at least maabot lang siya sa babaw. So assume that the constant retarding force due to friction is 60 kilograms, meaning to say that's the um, retarding force F, or that's the frictional resisting force, which is constant all throughout um, its traveling. So that's 60 kilograms. Alright, so first is we're gonna have um, the free body diagram of this car when it approaches upward. So we're gonna copy that, and it's going to approach and that incline. I'm gonna crop this out. Okay, so this angle here of inclination with respect to the horizontal is 20 degrees. And then the car has a weight of, or mass rather, so it has a mass of 1000 kilograms, or that's to be multiplied with 9.81, and that's 1000 times 9.81, that's 9810 newtons. And then of course there is a normal force, so there is normal force, and that is equal to n. And since the motion is padong dito, no, then the friction would be here, that one. And also we have we don't have coefficient of friction man, diba? So manang diretso na lang ta with the friction F, of course. And then acceleration, so pila na siya. So from here padong didri mahimo siyang no, there is no gaining of energy, diba? Kay from this point there is a velocity, a value not equal to 0, and at this point here there is a velocity that it is equal to 0. So the travel requires much energy until it becomes 0. So there is what we call deceleration, no, deceleration siya kay naaman siya value not equal to 0 from the initial, then from the final mahimo siyang 0 kay niingon man siya that it will just coast to the top, meaning ma-land lang siya sa top. So there is deceleration. So where is the motion? A motion is towards here, that's the motion, and acceleration is deceleration, so it's opposite to the motion. So therefore the REF is bound there, that one, REF. And of course we need to get the component, this one. This is 9810 cosine of 30, no, 20. And then there is here also, this is 9810 sine of 20. So this is the angle, 20 degrees. Right, so from here we can now have the arrangement. Summation of forces horizontal equal to 0, to the right positive, to the left negative. So what we have is REF REF minus rather, then plus 9810 sine of 20, and then plus the F, and that's equal to 0. So we're gonna transpose this. It will become positive, and this is 9810 sine of 20, and F is, how much is F? 60. But we have to multiply this with 9.81 para mahimo siyang newtons. So REF is equal to 9810 sine of 20 plus 60 times 9.81. So the REF is 3943.818 newtons. And then we have the REF. REF is the weight over the G. You multiply with the acceleration, and that's equal to 3943.818. What is the weight of the car? That's 9810 over 9.81 times the acceleration, and that's 3943.818. So that would be 3943.818 times 9.81 divided by 9810. So the acceleration is 3.944 meter per square seconds. But this is not our final answer, diba? Our final answer derives from this one. No? We're gonna find the distance that the car travels. So pila na siya nga distance from here padong diha. So we're gonna find this distance first before nato makuha ang initial velocity. So we're gonna call that as S. Where is S can be found? From this function of sine. No? So solving for S, it's sine of 20, and that's equal to 12 over S. So our S distance, that is 12 over sine 20. That's 35.086 meters. So that is our S distance. So from here, we can now find the initial velocity. So there are three equations. The final velocity equal to the initial velocity plus minus acceleration times time. We have final velocity square equal to the initial velocity square plus minus twice of the acceleration times the distance. Then we have the distance equal to the initial velocity times time plus minus 1/2 of the acceleration times the square of time. Okay, so we're gonna solve using this one, as we are finding the velocity of approach, meaning we're gonna find for the initial velocity. Again, it costs here, therefore the velocity final is 0. So this is 0 square equal to the initial velocity, as initial velocity is the approach velocity, and this is deceleration. No, that is deceleration. Do not forget that. No, we obtained a negative value and a positive value because we already assumed that it is deceleration. No, so it must be negative there. So twice of the 3.944 times the distance of 35.086. So the initial velocity of approach of the car to just coast the top of the incline is the square root of 2 times 3.944 times 35.086. So that's 16.636 meter per second. So that is our final answer.